We are looking at inverse of a function. So to find the inverse of a function, there are steps that we need to go through. The first step is that we swap x and y. And I want you to remember that y is the same as your f of x. After doing that, you make y the subject. That is, you are solving for y. And when that has been done, you now replace your y with f inverse of x. We may also be required to sketch the inverse of a function. When sketching the inverse of a function, the following must be done. We need to sketch the function using the main features, which we dealt with in grade 10 and 11. When the graph of f is drawn, you then draw in dotted line the graph of y is equal to x. Once that has been done, you then reflect the main features on f into the line y is equal to x. And then you can sketch your inverse of the function. Please take note. The coordinates on f say they are x. Then it means when we are identifying the coordinates of f inverse, then they should be y and x. Why? Because y is equal to x, or x is equal to y. I'm going to look at 3 examples, and we start with example number 1, and I read, consider the straight line y is equal to ax plus q if f of x, remember f of x is our y, if f of x is equal to y is equal to 2x plus 2. Find the inverse f inverse. In other words, this should be in brackets. So we start. Y is equal to 2x plus 2. The rules says when we are finding the inverse, we first of all swap x and y. So wherever there is y, we swap with x. Wherever there is an x, we swap with y. So it will be x is equal to 2y plus 2. Solving for y, we shall transfer our 2 to the left-hand side. It becomes negative. Then dividing both sides by 2, we shall have y is equal to x minus 2 all over 2. Then the rule says replace y with f inverse of x. So f inverse of x is equal to x minus 2 all over 2. Now, if we are to do this graphically, I have color-coded all my graphs in order for them to be clear to you. The green graph stands in this case for our f, and the red graph stands for f inverse of x. And the yellow graph represents y is equal to x. Now, when sketching a line graph, we all know from our grade 8, 9, 10, and 11 that we first of all think which method to use. For example, in this case, if we use the intercept method, you will know that on the x, y is 0. So if y becomes 0, you then solve for x. Your x is minus 1. And on the y, x is 0. So when x is 0, you solve y is equal to 2. So these are the coordinates. Remember we said we draw the line y is equal to x. This is our f. What are the main features? Is the point on the x-axis and the point on the y-axis. So it means if we are reflecting this point in the line y is equal to x, we have 0 minus 1, which means it's right here. And for this one, x becomes 2 and y becomes 0. So it's 2 and 0. So those 2 points are enough for us to sketch the red graph, which is F inverse.
Yeah.
Okay, there was a point here which is not necessarily supposed to be there. These are the points that you need, and you can now sketch your F inverse. That is when we are doing it graphically, but when we are answering this question, this is what is required. Let us move on to example number 2. If f of x is equal to 2x squared, find f inverse. First step, we swap our x and y. So wherever there is x, we put y. Wherever there is y, we put x. So y is x, then your x squared becomes y squared in this case. So solving for y, we shall have y squared is equal to x over 2. And then our y is plus or minus the square root of x over 2. So our inverse is y is equal to plus or minus root of x over 2. This is answering the question as is instructed in the question. But however, you can also want to do that graphically, as I said. Again, I color-coded the graphs. The one in blue is the F, the one in red is our F inverse, and the one in yellow is our y is equal to x. Let me write it here. Y is equal to x. Important. Let us all concentrate on the graph of F, which is the blue graph. You will notice that we have 2 points that are indicated. And these are the points that we reflected in the line y is equal to x. Remember, when we are reflecting in the line y is equal to x, x becomes y, y becomes x. So the 2 becomes the x, the minus 1 becomes the y. That is why we have this point. And on this one, we have 1 and 2. It means when we reflect in the line y is equal to x, we shall have 2 and 1. Very, very important. And I will demonstrate more on this when we do the restrictions to make this graph, the red graph, to make it a function. You can see from our study, if we draw any vertical line, it will cut the red graph twice. Therefore, it means it is not a function. It will only cut once if it is a function. So we always restrict the domain of the graph of f such that its inverse becomes a function. And that is what we are discussing here on this part. Restriction of domain of f of x is equal to 2x squared. This is the original graph that we have spoken about. We are saying the graph is, I come back here, the graph is the blue one. So for us to make the red one a function, we need to restrict the domain of the green graph, of the blue graph, which means if you are at the turning point of the blue graph, you notice that there is x to the left, which means x is less than 0, and x to the right, which means x is greater than 0. So to restrict this graph such that its inverse becomes a function, we are going to consider what is in the first quadrant. This is the graph I'm talking about. This graph. If you look at this graph, it is telling us that there is a point 2, 1, 2, which we can reflect into the yellow graph, which is y is equal to x. Then it becomes 2, 1. So it means this now up to here is the inverse of this graph after restriction has been done. By the same explanation, this other part of the graph is also reflected in here, in the yellow graph. It is minus 1, 2, it becomes 2 minus 1, which means this here is the reflection of this part. So our restriction is basically x is greater or equal to 0, which means we are taking this part only and its inverse is that one. Now the red graph now is a function. It is the inverse of the blue graph, but it is also a function because it passes the vertical line test. If you draw any line, it will only cut once. The same applies to this part, which we have also explained. It is reflected here, and this now is now also a function. So the inverse of a quadratic function, to be a function, we need to restrict our domain for the graph f. We need to restrict the domain of the graph f. Then we are going to do the exercise now. It will be classwork, exercise 2. We do numbers 1, 3, and 5. And your homework will be exercise 2. You do numbers 2, 4, and 6.